Today we're starting section 1.8. We're looking at some properties of exponents. We briefly talked about exponents in a previous lesson, so this is going to build on that. So we're going to take a look at the properties of exponents, and I'm going to justify why each of these is true. Not because I'm expecting you to justify it later, but if you have one of those moments where you can't remember why something works, I want you to be able to sort of reason through what it should be in case that happens. So the first property of exponents says that if I have a base to an exponent and I have the same base, a, to a different exponent or even the same exponent, I can add the exponents together. So this is a to the m plus n. And we'll do an example with some numbers, or there has some numbers in it to talk about why this happened. So for example, if you had a cubed times a squared means a times a times a, right? This is a cubed. And a squared means a times a. And if you take a look at simplifying that back down into a single expression, how many a's do you have? 5. So you can see that indeed we took the 3 and the 2 and we added them together to get 5. Right? So if you forget this property, you can actually do a simplified example and you can very quickly find out, oh yeah, I'm supposed to add the exponents together. So if the first one, where it looks like multiplication with these exponents, means that I end up adding the exponents, what do you think is going to happen if I do division?
Subtraction.
It is, it's subtraction. So it's the top exponent minus the bottom one. And again, I want to justify for you why it works with an example. So we're going to do a to the 4th over a to the 1st. So a to the 4th means I have 4 a's. A to the 1st means I have 1a. And one of our properties of fractions that we looked at said that if I have it all multiplication on the bottom and I have it all all multiplication on the top or the bottom, I can look at factors that reduce. So one of these a's from the top and the bottom will cancel out. That leaves me with 3 a's on the top, otherwise known as a cubed. So how do I get from the 4 and the 1 to the 3? Subtract. So that's the second property. The third property looks a lot like the first one. What's different? There's parentheses. What else? There's not another a, right? So when I have an exponent, right, a base with an exponent, and then an exponent on the outside, what I will do is I will multiply the exponents together. And we'll use the same 3 and 2 that we had before, so we're going to do a cubed squared for our example. So a cubed means I have 3 a's. Squaring something means I multiply it by itself. So I have a. How many a's is it? It's 6 a's. So this is a to the 6th. And how do I get from 3 and 2 to 6? Multiply, right? Okay, so all that okay so far? Again, I'm not going to ask you to justify why these work. That's not the point of what I'm doing. You're just going to need to know that they do work and be able to utilize them. But if you forget, hopefully hearing the justification will allow you to figure it out. All right, let's try some more. We have 4 more properties. All right, this one, a times b to the m. So Chase, you asked about distributing over parentheses that had addition and subtraction, and we both said that doesn't work. It does work with multiplication, though, and division, which is properties 4 and 5 here. So when I have multiplication inside the a times b and I have a power m, I actually am able to distribute the m across to the a and the b individually. And the real reason why is because I have the ability to use commutative and associative properties. So if I had ab cubed, what it would mean is that I have ab times ab times ab. And one of the properties that we talked about a couple sections ago was that we have the ability to shift values, right? If it's all multiplied, we can regroup all the multiplication in a different way. That's commutative and associative properties. So this is able to be rewritten like this. I have 3 a's that are being multiplied. I have 3 b's that are being multiplied. And lo and behold, there's the a cubed, b cubed coming out. And you can see the distribution property happened. It's even easier to see with division, actually, because you don't feel like you have to shift anything around. So if it's divided, you also have the ability to distribute the exponent. So if we have a over b cubed, it means I have a over b times a over b times a over b. And this one, Gabe, is a lot like the one that you brought up today when we were looking at questions, where it's repeated multiple times. We multiply it across the top. So this is a times a times a. Across the bottom, b times b times b. Well, that's a cubed over b cubed individually. Okay, so it distributes just like we would sort of innately expect it to do. The next two are a bit more interesting. Does anybody remember what a to the 0 is? It's 1. This one feels a little bit like it's magic. It's not magic, and I want to show you actually how it works. And this is actually a legit proof for why it works, because I can do it with general terms very easily. So we're going to rewrite a to the 0 in a way that feels a little bit funny, but it's true. If I have a to the n minus n, does it equal a to the 0? Yeah, n minus n is 0, right?
Yeah.
So you might look at that and think, well, why did we do that? But you should be at least able to say, yeah, it's true. Is it true? Mm-hmm. It's true. And what we're going to actually do is we're going to use property number 2 over here backwards. We've got something that looks like this, a to the m minus n, and we're going to put it back in fraction form. So that puts us into a form that looks like a to the n over a to the n. And what happens when you divide something by itself? You get 1. So anything to the 0 power really is 1, and it doesn't matter what that value is, as long as it's not 0. A can't be 0 to make that work, but anything else works. Number 7 we can actually do in much the same way. So on number 7, this is actually 1 over a to the n. So if you have a negative exponent, you can move it into the denominator and make it a positive exponent. And I can do that again with a very quick actual proof. These are actually proofs. The other ones are more like justification by example. So this is actually a to the negative n, the same as a to the 0 minus n, right? And I can do the same trick that I did before, where I write the a to the 0 on top, and I can write the a to the n on bottom. And what did we just decide and learn that a to the 0 was? It's 1. So I have a to the n on bottom. Okay, so those are all the properties we're going to have. That's it. And what we're going to do now is we're going to actually have problems that we use those properties on. Okay? So these are our properties we're going to keep referring back to. I'm probably going to ask you from time to time, which property is that? You can just tell me 1 through 7, that's fine, and we'll move on from there. So let's do some examples of ones that actually look like what we're dealing with. Okay, so on problem number 1, we see a squared times a to the 5th, I'm sorry, not a, they're x's. X squared times x to the 5th times x to the 4th. What property can I use to combine these together? 1. This is property number 1. There's 3 terms, but it doesn't matter. I can have as many as that I need as long as the bases all match, and they do. All the bases are the same. They're all x. So what do you suppose I'm going to do with those exponents? Add them all together. So if you add 2 plus 5 plus 4, what do you get? It's 11. Yep. X to the 11th. There's nothing to show to do that. That's probably some of your favorite thing right now. She just told me I didn't have to show anything. Yeah. All right, second one. Okay, so on the second one, we have coefficients and we have variables. So we can deal with them all separately. I can deal with each of the coefficients, because it's all multiplication. So I can deal with each of the coefficients first, and I can multiply them out. So I can multiply negative 4 times negative 3 times negative 2. What will that give me? Negative 24. Everybody get negative 24? Yeah? Good. Okay, and then the other pieces are the y's. So I have y squared, I have y cubed, and I have y. And if you want to write them separately just to push them together closer, you can. The y at the end has an understood exponent of 1, if that helps. Those y's now look a lot like problem number 1, right? Where I'm using property number 1. So what is y squared times y cubed times y to the first? Yeah, it's y to the 6th. In some ways, problem 3 is easier because there's no negatives. In some ways, it's a little bit different because there's x's and y's. That's okay. We deal with it in much the same way. We're going to deal with the numbers all first. So we have a 6 times a 4 times a 2 times a 3. So grab a calculator if you wish. What is 6 times 4 times 2 times 3? You're doing a good job in your head real quick. Can you get there all the way? Mm-hmm. Yeah, it's 144. And you can definitely use your calculator. That's not an issue with me, right? We can use your calculator for that. That's okay. Taking a look then, typically speaking, we go in alphabetical order, but if you don't, it doesn't really matter. So you can pick the x's or you can pick the y's to go with next. I'm going to pick x's because I'm a little OCD. So I'll go alphabetical. There's a couple of x's here. There's an x cubed and an x. So what is x cubed times x?
X to the 4th.
Yep, that's x to the 4th. And then the remaining values are the y's. So I have y squared and y cubed, y to the 5th. And again, if you wrote it as 144 y to the 5th, x to the 4th, that would be fine. Is there a typo on something?
No.
Oh,
Something James said earlier.
okay. All right, is this one all right? We're okay with it? Okay, cool. Let's move on to number 4. What property do you see happening on problem 4?
Property number 3.
Property number 3, right? Is it 3? Yeah. Oh, do you have a question?
Yes, so regardless of the exponent, you still multiply all the numbers together.
Yep. Yeah, and the reason that you can, that's actually good that you mentioned it because now that I'm thinking about it, I do often have people just do the parts that have x's together and the parts that have y's together. The numbers and the variables can be shifted in any order because that's a property of real numbers. I have the ability to commute values, so I can just shift them for all multiplication. Right, so in a very real sense, what we're really doing is we're saying that I can move all the coefficients to the front, like that, because I have the commutative property that allows me to shift things around. And I can do all the x's next,
Oh, okay, yeah.
and then I can do all the y's.
That's what I thought. I was just 144. Oh, okay.
I think it equals the same. It's just
Are you guys good?
Yeah.
It's all good? Jacob's like, I don't know. This is all good? You good, Simon?
I think so.
I think so. Okay. Well, we'll see when we get to work, right?
Yeah.
Okay, that sounds good. All right. You guys said that we're going to do property number 3, I think, on this one. So property number 3 on this one says, what will I do?
Subtract the exponents.
Not subtract, not add,
Multiply the boy.
multiply, third time's a charm. Multiply the exponents.
Looking at.
Okay, we're on, oh yeah, it's not, it is property number 3. It's this one right here.
Yep.
All right, a to the m to the n, going to multiply the exponents. All right, so what is 2 times 4? 8. Okay, James, are you good?
Yeah, we're good.
Okay. Chase as well? Yep, all right, great. How about number 5? What property will I use for number 5?
Property number 2.
Yeah, it's property number 4. Property number 4 because there are 2 pieces that are inside that are both being raised to the exponent, right? So this 3 has to apply to both pieces. If you'd like to write out 4 cubed first, you may. You certainly don't have to. But you can't leave it as 4 cubed because you know what 4 cubed is, or at least you can find it. What is 4 cubed?
64.
It's 64. So our final answer needs to have exponents only on variables because numbers with exponents can be simplified. Okay, 6 is the first one that has multiple properties in the same problem. What properties do you see happening on number 6?
3.
Property number 3. There's another one too. Property number 4. Yeah, so property number 4 is sort of the overarching one. I've got an exponent on the outside and it needs to distribute to each of the pieces inside. So this 3 will distribute to the 3, it will distribute to the x, and it will distribute to the y squared. So I'm going to write that out. If you don't need to see that written out, that's okay. But right here at the end where I have the y squared cubed is where you're seeing property number 3 taking place. Because there is a power to the power on the y. Now there's not on the 3 or on the x. It's just a single distribution property number 4. It's just that. But on the y squared, it does have property number 3 taking place. So what is 3 cubed?
27.
27. The x is already as simplified as it can get. It's x cubed. What will y have as its exponent?
6.
6. Okay, property number 3 says we multiply the exponents. 3 times 2 is 6. Okay, doing okay? Got lots of examples for you today. Okay? Number 7. What would you like to do first? The exponent on the outside? Sure, distribute. Okay, so that's property number 4. So we have to distribute it to the 2, the a, and the b squared. But we also have to distribute it to the negative. The negative is also cubed. There are 3 negatives in play. So if I have a negative times a negative times a negative, 3 negatives, will my answer be negative or will my answer be positive?
Negative.
It will be negative. So my answer has to be negative because I have cubed the negative. I'm also cubing the 2. So what is 2 cubed? It is 8. 2 cubed, not 2 times 3, but 2 cubed is 8. On the bottom, a cubed. That's just a cubed. But then here I have b squared cubed,
66.
b to the 6th, much like the last problem, right? And if you want to see more pieces of that, you can. You can write more of that out. Okay, number 8 looks easier. It looks easier than the last ones because I don't have any parentheses, I think is probably why it looks easier. Much like when we had over here, the one that we were talking about, number 3, where I can put all of the coefficients together and I can do the multiplication. Over here, I can think about the coefficients separately from the variables as well. I can think about 14 and 35 just like I did when I didn't have any variables attached. 14 and 35 both reduce. What do they both divide by? 7. So if I divide 14 by 7, what will I get? 2. And if I divide 35 by 7, what will I get? 5. I don't like that green. I should be using something darker. Let's try that one. Okay. Now, on this one as well, we see we have an x over an x. We can reduce those 2. Yeah, they cancel. They both divide by themselves, so they cancel to 1s. And then the y doesn't have anything to pair up with. So on the top, I'm left with a 2, and on the bottom, I'm left with a 5y. All good?
So why would there be a 1? Like, because x over x is 1. That's a whole number. So this is the question. Why would there be a 1 next to it?
Like right here?
No, it'd be 1, 2 over 5, 1. Like 1 beside.
Because it's multiplication. Is this what you're talking about?
Oh, okay, you're so right.
Yeah, you're still multiplying the pieces that remain. Yeah, so there is a 1 there, it just doesn't affect the value. Yeah. And the same thing down there, it's not a 51, it's 5 times 1. Yeah.
Did we like, I don't know how, like, did we reduce it by 1435? Did we just split it in half?
We divided them both by 7.
Oh, so what?
So on the top, it's divisible by 7, and on the bottom, it's divisible by 7.
Okay.
So 14 divided by 7 was 2, and then 35 divided by 7 is 5.
All right.
Okay, let's take a look at another one. Number 9. There's several ways we can do number 9, but I want to actually show you how you can use the properties to your advantage here to do this. This isn't the only way to do the problem, and if you do it differently, it's okay. So notice we have an x squared on top and we have an x on bottom, right? That's actually very much like property number 2. I have an x to a power on top and an x to a power on bottom. So one way to deal with this is to simply subtract the exponents. The exponent on top is a 2, the exponent on bottom is a 1. And I can do the same thing with y. The exponent on top is a 6, the exponent on bottom is a 2. So I can do cancellation much like I did over here on problem number 8, and I can do that, and that's fine. And if you want to do it that way, it's great. But eventually the numbers will get larger, and you might not want to actually do it that way. So you can use property number 2 if you wish. X is to the 2 minus 1. 2 minus 1 is 1. So you can either write x to the 1 or you can just write x. How about the y? What's its exponent? 4. xy to the 4th. Number 10 I can do that with as well. You see the setup looks very similar to number 9. U is to the 1 minus 4. And then W is to the 2 minus 6. But something a little bit different happens when I subtract these. What happens? Somebody said it. You get negatives, right? We didn't get negatives on the last one. That's okay. U would be to the negative what? 3, thank you. And W would be to what? Negative 4. The caveat to doing this, however, is I don't get to stop here. I could stop here on number 9 because my exponents were positive, but if my exponents are negative, I need to do one more step. I need to apply property number 7. Property number 7 said if I have negative exponents, I can drop them into the denominator and make them positive. So I will drop both of these into the denominator, and they will become positive. So U cubed and W to the 4th. And the numerator is now a 1. So my final answer should have no negative exponents. Again, it's not the only way to do the problem. If you want to do some cancellation with the problem, you're more than welcome to do that. That's not a problem. You can do it from that perspective.
Oh, so you can't leave the exponents negative.
Correct. Do not leave your exponents negative. Do not leave negative exponents. Okay, next one. We see a power that we haven't seen yet since I did the properties. That power is 0. So everything that's raised to the 0 here, which is the 4 and the W, becomes the number 1. So there's still a negative 3 at the beginning, but everything in that red kind of circle there is now 1, and negative 3 times 1 is negative 3. So don't inadvertently see I've got a 0 power, everything cancels out to 1. It's only the pieces that are raised to the power 0. In this case, the 4 and the W. All right. I want to show you what happens on number 12, because we haven't seen anything like this in our rules. They're at play here, but there's easier processing ways of doing this. When you have a negative exponent, right, that's property number 7. It says the negative exponent pushes something into the denominator, right? That's what it says. But what it really means is that it takes something that's a to the negative 1 over 1, and it does the reciprocal. It puts the 1 on top, and it puts the a to the n on bottom. So it flips things upside down. That's what negative exponents do. They flip things upside down and make them positive exponents. So when we're working with this one right here, that's going to be a really helpful tool. I still have the 2u and I have the 3, but they flip. The 3 is now on top and the 2u is on bottom. And the exponent is now positive. So the negative goes away when I flip it. The exponent I still have to deal with just like I dealt with before. I distribute, and I'll distribute to the 3, to the 2, and to the u. What's 3 squared? 9. What's 2 squared? 4. And then I write my u squared. So negative exponents flip things. Now, the cool thing is that it happens here as well. Now, we can combine these first. This is the property number 1. X to the negative 3, x to the negative 6. What do I do with the exponents? Yeah, I add them. So I have negative 3 plus negative 6. And what is negative 3 plus negative 6? Yeah, Tristan, you got it. Negative 9. So it is still negative because they were negative when they started. So it is negative 9. But like we were talking, Nolan, I can't leave it there, right? Where do I drop it? Below the division line, right? So this becomes x to the 9th on bottom and the 1 on top. Now, if you want to deal with it from that perspective here and drop them at the beginning, you can do that too. I can drop the x cubed and the x to the 6th in the denominator from the start and then combine the exponents as well. I'll still get x to the 9th in the denominator. Okay. Along the same lines, number 14. A couple different ways to do it. I'm inclined to just add the exponents together first. If you're not inclined to do it that way, that's fine. So I would take negative 1 plus negative 5 plus 4. What is negative 1 plus negative 5?
Negative 6.
Negative 6, and negative 6 plus 4 is negative 2. So just y to the negative 2. And then how will I get the exponent to be positive?
Drop it down.
Drop it down.
1 over the top, and turn the exponent to a positive.
You bet.
If it were to be negative y times y negative 5 and y 4, would it be the same thing?
Yeah, you just put the negative out in front of everything. So a negative in front of a coefficient, like it's acting like a coefficient, just like a negative
the y
1.
without an exponent is an understood 1.
It is.
So if it's a negative y, it would be an understood negative 1.
Yep, exactly. Okay, last one. This one has the most going on. There's distinctly 2 different ways you can do it, and I don't really know that I have a preference. Your first option is you could distribute the negative, or you could flip them because it's a negative 3. A second option is you could simplify inside the parentheses with properties of exponents first. So what would you guys like to do? Would you like to flip it first, or would you like to simplify inside first?
I'd say flip it.
Flip it. I hear flip it as my most prominent voices, so we'll flip it. So the part that's inside will flip upside down. So the denominator, which is x to the negative 2y, will come up to the numerator. The numerator, which is xy squared, will go to the denominator. Notice I didn't change this x to the negative 2 to positive. The flipping changes the negative sign on the 3. So that's now 3. Okay, so just because I moved them because of the negative on the outside with the 3. That's the sign that changes now to positive.
Which means you would have to flip it later, right?
Yes, and in fact, if you want to, BJ, you can even do it now. If you want to move this x to the negative 2 down, because it's negative, you could do it here. And so since we kind of pointed that out, I think I'll show you that way here. So here's a y on top. The x to the negative 2 is now moved to the denominator to be x to the 2. The x that's already there is now an x, and there's a y squared there as well. There is a plethora of ways that you could operate this and simplify everything. Lots of options. I'm just showing you one.
So that's one way.
We're not done, but this is one way, yeah. Are you okay, Keaton? No? It's okay.
And then from there you would just distribute.
It comes better when you were practicing. We can distribute, but I actually think simplifying my x's and y's inside might make it easier first.
The X's and the,
Huh? I didn't cross anything out yet.
oh, yeah.
All I did was I moved this piece down to your x squared.
Oh,
Oh,
be impossible.
Okay.
Yeah. Are we good now?
Okay.
Okay. Is everybody okay?
It's moved down. I
You're kinda
glanced
confused?
For like 1 second and I got lost.
Okay, how about I do this one way and then I'll show you another option. Would that be okay?
Yeah.
And maybe you like it better. Okay, let's do that. Okay, at this point, I'd kind of like to combine my x's. I've got x squared times x in the denominator. What is that? X cubed. So I have an x cubed in the denominator. I also have a y squared on bottom and a y on top. Can I reduce those?
Yep.
Sure. I can reduce those even without properties by recognizing my properties of fractions, right? One of the y's on top cancels with one of the y's on bottom. That doesn't leave me with anything but a 1 on top. And
That's why I got confused.
and it leaves me with the 1 on bottom.
Why didn't the y squared on the bottom flip back to the top?
Because the y squared on the bottom was already positive.
Oh,
Yeah. So we only move things if they have negative exponents. And the reason, again, we moved everything at the beginning was because the negative on the outside applied to everything. All of my exponents were negative over here, right? The -3 on the outside. This point, I can distribute my cubes. So 1 cubed is 1. What is x cubed cubed? Yeah, x cubed cubed, that's property number 3, is x to the 9th. And then I had y cubed. I'd like to show you another option, though, since some of you did not like my option that we went with. Let's actually deal with the parenthesis part inside first. Okay, let's just deal with everything inside the parentheses first. So if I do that, I have x, y squared, x to the -2, whoops, should be -2, and y. All right, so if I deal with everything inside first, that x to the -2, BJ, that we were talking about, it's going to move up. And it's the only one, because inside the parentheses, it is the only negative exponent. Everybody good with that? Yes? Okay. So if I think of it from this perspective, the x squared will move up with the x and the y squared that are already there, and the y that's in the denominator is left by itself. Okay, is that good? Okay. I can combine the x squared and the x now. X squared times x is x to the 3rd. And I can also notice that the y squared on top and the y on bottom will reduce to what? Y on top. I'm going to leave it as a 1 on bottom because I'm about to flip it anyway. But if you just worded it as x cubed to the y, x cubed times y, that'd be okay. Is that all right?
Yep.
Okay. Now the negative on the outside can flip it. So now my 1 is on top, and my x cubed y is on bottom, and my exponent on the outside is a positive now because I flipped it. Okay? And then I can distribute the cubed. This was the last step I had on the other way too. So I have my 1 cubed is 1. My x cubed is x to the 9th, and my y cubed is y cubed. And this isn't even all of them. There's other things we could do to get to this same point, and they're all interchangeable steps along the way, so they still get you there.